All right. We'll discuss some questions related to these units and dimensions, right? So then we can finish this part, then we can start the measuring instruments, the next part of this question, this lesson, right? All among other the questions, कराद मारू या can be discuss करते. So then I will send you some MCQ questions also. This hard copy of this all tutorials I will give at the physical class. Most probably we can do the physical class in this week. So I will come. You let me know that you can come or not. Right. Later in the පුළුවන් නේද? පොඩ්ඩක් ගහගන්න පුළුවන් වුණා like here. First I will give you the question and then I let you know how to get the dimensions for unknown quantities. Right. So first write the question. This question right there. Van der Waals equation. Sorry, that question also there in the question set given. So that third question will do. Right, this question I will give you the third question. I'll discuss this. That question is yes, sorry. First we do that thing. It is better than. All right. So the table first we discuss. Then okay. So all the dimensions you have to know before you going to do this question because that is better. Sorry. Go to that one. Okay, this dimensional formula list. To take it first, then we will discuss and then go to next one. So here, the first one they given that is the area, right? These all are all, but I'm not discuss all them. So I'm not going to write this formula. I'll write the this quantity dimensional formula and it's a unit, right? So that dimensional formula is area, it's L square. So its SI unit is square meter, right? You check your answer correct or not. And then second one, it's volume. So dimensional formula is L cube and this is a meter cube. Third one, density. This ml minus 3. Ml minus 3. Density is the mass divided by volume. And this is kilogram per meter cube. The specific gravity that specific gravity is the ratio of two densities, right? Density of substance divided by density of water. So both having the same dimension, so they cancel out. So then for specific gravity, there is no dimension. No dimension, right? So you have to write that no dimension. Or you can write in this format also. That is M0, L0, T0. That's the way of we are writing the no dimension. And this the SI units, it's no units. Having no units and no dimensions. The specific gravity. This also means the relative density. The same name, specific gravity and relative density are same. And the fifth one, frequency. Frequency, the number of oscillations divided by the time taken. So number of oscillations is a number, so no dimension for number. But in it, you cannot. That's no dimension, right? So for the sun, is you can use this one, and the time taken means is a dimension of time. So then it's the unit dimension of formula is t minus one. So you can write it as t minus one, right? Dimension for the t minus one, and its SI unit is hertz. The hertz means that is per second. Per second, it means the hertz, right? So we use this SI units, SI symbols. We have to use it. The sixth one, plane angle. Plane angle is arc divided by the radius that both are in. So then no dimension for that. Right, no dimension. And but they are having unit, that is radian. Unit is radian, right? Seventh one, the velocity. Velocity. Its dimension of formula is LT minus 1. The length, the displacement divided by the time. So its the unit is meters per second. The speed are same as the velocity. Only difference is this is a vector, this is a scalar quantity. So its units and dimensions are same as the velocity. Ninth one is the acceleration. So its dimension of formula is LC minus 1 because that velocity divided by time again. And this is meters per star second. Tenth one I'm writing here. And linear momentum. Dimension of formula is MLT minus 1. This is mass into velocity. And the mass is MLT minus 1 into velocity. So its unit is also you can write kilogram meters per second. Or you can write this as a Newton second. This both we can have the kilogram meters per second or Newton second. Okay. Is it okay up to this point? Because I will go to the next page. If you have any questions, any doubts, points, you can tell me, then I'll explain again, right? And the 11th one, the 11th one is the force. Force is the mass multiplied by the acceleration. This mass is dimension is m. The acceleration has a dimension LT minus 2. So MLT minus 2 is unit is Newton. Right. SI units we need to use, not the kilogram meters per second. So it is not the SI unit. SI unit is a Newton, right? 12th one, torque. Torque is a moment of the force. The force multiplied by the distance. The force MLT minus 2. Let's multiply by distance, then it's become ML square T minus 2. T to the power minus 2. MLT to the power minus 2. And its unit is Newton meter. Yeah. The any case you can write that it's LT minus 1, or you can write this as M0 LT minus 1. Any case, if the other quantity is not there, you can write it as a zeroth power of that. or you can omit that one. මේක naturally end up පුළුවන්. Even නැත්නම් you can write that the quantity with the zero power because the zero power is 1. It's okay. That's LT minus 2 also you can write for acceleration as m0 LT minus 2. Or no dimension 1, you can write it as zero of all quantities. Format anyway you can write this. Okay. That's a talk. Then impulse. Impulse is the force divided by the time. So then this one divided by time means this become ml. Sorry, the impulse means force multiplied by time. So this will multiply by time means mlt minus 1 is become. So this impulse has the same dimension as the linear momentum. Linear momentum impulse has the same dimension. So its unit is Newton second or Newton kilogram meters or meter per second. Right, both way you can write. Is Newton second. 14th one pressure. This was divided by the area. So it's become ml minus 1 T minus 2. So its sign is Pascal. In some cases, we can write as newtons per square meter. That's the work. You know how it works as ml square T minus 2. Its sign is joule. It's 20 kg. So it's also energy. So it's ml square T minus 2. So this unit is same as the work. Potential energy. This also have same unit as the energy because all form of energy having the same dimension and same unit. The gravitational constant, the capital G. So its equation is given. I'm going to discuss this down. So that's a gravitational constant G is equals F r distance is square divided by mass is square. So then the dimension formula of F force is ml3 minus 2. Dimension formula of the distance is L square. The dimension plus the mass is m the square of that. So one m cancel. So it's become m minus 1. One cancel, there's one come to up with then minus. So then L square, so it will become L cube. And then T minus 2. So this is the dimensional formula for the gravitational constant. M minus 1, M cube, T minus 2. So its unit is same as this. You can write this kilogram cubic meter and square per square. This also can write this in a SI system. Oh, it's equal to the Newton square meter Newton square meter. The 19th one. Gravitational field intensity. Yes, that is the same as the acceleration force divided by mass. So it's units Lt minus 2 miss minus 2. Dimensional formula and the unit. 20th one, gravitational potential. That's work done divided by mass. So then I'll write how to make it and then write. Gravitational potential. I will write it V is the unit of that. So then it's equals to the work done divided by the mass, dimension of mass. The work done has a dimension ml square t minus 2. Mass is mm cancel, so it's become L square t minus 2. Right, so its unit is m0 L square t minus 2. You can write in this way. Without this m also you can write, right? And its unit is then joules per kilogram. That's work done is measured in joule and mass is measured in kilograms. So then it becomes joules per kilogram. How much joules of energy for 1 kilogram of mass. Right? Is it okay up to this point? Now then I'll go to the next part. All right. So I got next page then. 20 mark. That's force constant. That's force divided by length. So then it is m. L cancel out. So then mt minus 2. This is the dimensional formula of force constant. You can write this as ml0 t minus 2 also. Same way you can write this, or without L or you can write. So then its unit is Newton per meter. Newton per meter, right? That's 22nd power. The power is work done divided by the time taken. So it's become ml square t minus 3. Because that's work done is ml square t minus 2 is divided by the time again. So then it's become t minus 3. So its SI units is called watts or joules per second. It means watts, right? That's 23. Moments of inertia. The mass multiplied by the radius, the square of the radius of gyration. So then it's ml square. So this becomes 10 kilogram square meter. Next one is the stress. Stress is equal to the storing force divided by the area. This is same as the pressure thing, right? ml minus 1 t minus 2. The force divided by the area. The force has the dimension ml, ml t minus 2, and the area is L square. So then by simplifying this, you can get the ml minus 1 and t minus 2. So that's how it comes. The stress has the dimensions and units, the newtons per square meter. Then force divided by this. So we can call it a Pascal also. Strain. Strain is extension is divided by the initial length. Extension means also the length, and initial length is also length. So length divided by length is no dimension. Again, say no dimension, zero dimension, and no unit. Six Young modulus. Young's modulus. There is stress divided by strain. So this 24th one divided by 25th. So then no change because no dimension for strain. So then it's same as the dimension of stress or pressure. Unit is similar. So the one is the velocity gradient. This velocity divided by the gap over distance. Velocity as LT minus 1 divided by the gap means L. Gap is the distance, its dimension is L. Now L cancels, this becomes T minus 1. So its dimension formula is T minus 1. And its unit is, that's a hertz, so per second. Per second or hertz. So and its coefficient of viscosity. So its equation tangential stress divided by the velocity gradient. The tangential law anyway stress means this one. I stress has a dimension ml minus 1, T minus 2. Divided by the velocity gradient is T minus 1. So then by simplifying ml minus 1, T minus 1. T minus 2 here, T minus 1 here, 1 cancel. So its dimension of formula is ml minus 1, T minus 1. So its units is the stress divided multiplied by its units. Also you can take the stress as the unit m in m minus 2 newtons per square meter. So it's divided by the velocity gradient has the per second. So this is newtons per square meter second. So this is actually that's a Pascal divided by per second. So it's called a Pascal second. So mostly we write this as a Pascal second. So we in the industry we call it a Poise. A Poise එකක් කියලා කියනවා. Poises කියලා කියන්නේ. But you need to remember that's Pascal second. 29th on the surface tension. Surface tension is force divided by length, is same as the force constant. This is dimension is mt minus 2 and its unit is Newton per meter. The 30th one, angular displacement. Angular displacement, that is arc length divided by the radius. So no dimension. Because angular displacement is the angle is measured. So its unit is radian. No unit, no dimension, but they're having a unit. Right? So can I go to the next question? All right, and mostly the parts, right? 30. This angular velocity. So it's angular displacement divided by the time. So it's dimension for s t minus 1. Its unit is radian per second. The angular acceleration dimension of formula is t minus 2, and then unit is radians per second. Angular momentum dimensional formula, that is the moment of inertia multiplied by velocity. You remember that moment of inertia is ml square, and angular velocity has a dimension t minus 1. So its dimensional formula is ml square t minus 1. This unit is, that is a kilogram square meter just per second. Or you can write this as the radians per second also, or per second. And this is also, you can write as without radian. So also you can write this. The angular impulse is similar to the angular momentum. Impulse, same as your work. Fifth, linear expansion coefficient. Linear expansion coefficient. The length change and initial length and imperature. The length change, I'll take how to get it, right? Length change is the length, so its dimension is L. So divide by the initial length, multiply by the temperature change. So temperature has dimension. I have given you this. Temperature has a dimension, that is theta. So it is theta. You can LL cancel, then it becomes theta minus 1. So the dimension of orbit is theta minus 1 only. This unit is then, and unit of length and temperature change in SI is measured in Kelvin. So then its unit is per Kelvin. Or we can use this as a per Celsius. Six. Specific heat capacity. Specific heat capacity. It's a heat required divided by mass. Heat means that is energy. Energy has a dimension ml square t minus 2, and it's divided by the mass. Heat required divided by the mass and divided by the temperature change. So it has a theta. Mm cancels. So this dimension is square t minus 2 theta minus 1. So it is L square t minus 2 theta minus 1. And the unit is, that's the heat required means is the joules. Divide by mass means joules per kilogram. And divide by the temperature means per Kelvin. So joules per Kelvin per kilogram per Kelvin. This is a unit of specific heat capacity. Specific latent heat. The heat required divided by the mass. So this theta will not be there. So it's easily you can get T L square T minus 2. That's its unit is joules per kilogram. Finally, the Planck constant. Energy of a photon divided by the frequency, right? The equation you write related to this Planck constant, you write as energy divided in equals to the Planck constant into the frequency. So the Planck constant you can write in this way. So that's the energy as the dimension ml square minus 2. So frequency has the dimension t minus 1. Simplifying, you can write ml square t minus 1. So in units, so this is joules, this is per second. We come to up then joule second. Its unit is joule second. Okay. You can write another two. I'm going to give you. Add the another two, that 39. Write the energy density. Energy density. Write it formula as that's energy divided by the volume. Energy divided by volume. So then the dimension of formula I can write then energy has ml square t minus 2. The volume has L cube. Simplifying this, you can write dimension ml minus 1 t minus 2. So it has a dimension which same as the dimension of pressure. So its unit is joule. That's the energy divided by the volume is cubic meter. You can write it joules per cubic meter. Or is it similar to the Pascal? It's energy density, right? It's also important one. And the 40th, so last one is the right as flow rate. Flow rate. That's volume flowing. That's divided by the time. Volume divided by time. So it is dimension of formula is L cube T minus 1. And its SI unit is this cubic meter per second. How much cubic meter of liquid or anywhere flowing per second. That's a flow rate. Right? Okay, you can note it down and let me know. Dots theorem. Hal cenderung juga disahkan tuh. Right nih. Right. Let's clear the questions. Nih. Okay. Questions what end up coming pretty pretty okay. Ultimately the end very weak. Weak. I could have keep it there. Filter again. The dimension of analysis we can't use because there are some limitations. So we'll discuss about those limitations. Okay. So right here, that's in the notebook, right? The dimensional analysis limits. I put a stand, then dimensional analysis limits dimensional analysis limits its usefulness in constructing equations. In constructing equations, its limits. What are the limits then? So we discuss them. You know, when you construct equations, that deriving the equations using this dimension analysis, then remember that the method we followed, we will write as dependencies of those things, and then we write the equation with the indexes, and then we have to find that indices, right? When you find the indices, you can write three equations by equating the dimensions of that's powers of mass, length, and time. Basically, this. So using this, you can get only three equations. Right? If there are more than three unknowns, with having a three equation, it is difficult to find it. So that is a one limitation. If there is more than three quantities which depends on the one, so then it is difficult to derive the equation using this dimensional analysis. Yeah, so that's the first fact you can write. But in that in this case we can use it is in the another way. Another way means let's see, if if one quantity, let's say A, is depends on the four quantities like B, C, D, and E. So then we can take this two as a one. As example, let's say that's a in the case of pressure, you divide by length. The pressure and length you can take as two quantities, but the pressure dividing by length you can take it as one quantity. So we call it a pressure gradient. That way, we can reduce these four quantities into three, and then you can derive the equation as you want. Okay, so that's what there's a limitation if there is more than many quantities which depends on another one. So it is very difficult to derive the formulas or equations using this dimension analysis. And then write that limitation there, the superstrong. Write it as superstrong. Here, here, the equations are constructed by, here the equations are constructed by the dimensions of, constructed by the dimensions of mass, length, and time. Mass, length, and time. That is M, L, and T, right? So only three unknown terms can be solved. So only three unknown terms can be solved. Thus, there should be a maximum of 4 physical quantities. The maximum 4 means that is 3 dependence one and other one. Other one is the we have to construct the equation for that quantity. That's right. Thus, there should be a maximum of 4 physical quantities on either side of the equation. On either side of the equation connected by dimensional analysis. Connected by dimensional analysis. Right. That's a one limitation. And then second limitation is right. That's a proportionally constant or dimensionless constant. We cannot determine the value of this dimensionless constant using this dimensional analysis. We can't say anything about the dimensionless constant. If it is whether that means whether it is wrong or correct, is correct condition. So we cannot write anything. We cannot tell anything about this dimensionless quantities using this dimensional analysis, right? So that's why when you derive this, when you check the accuracy of the equation, also we need to write that the equation is correct under the dimension. The dimension is correct. We cannot directly say that is a correct equation or not. That we can say only it's dimensionally correct or not, right? So that's also the limitation. Here that also you can write there. The dimensional analysis can't be used to find the values of dimensional analysis cannot be used find the values of dimensionless constant. Values of the dimensionless constant. Dimensionless constant. And also you need to know that this method we cannot use uh, cannot be used to derive an equation with having some summation or subtraction terms, right? This method we can write to derive the equation uh, that's connected by multiplications or divisions only. We cannot derive an equation like this. The v square equals u square plus 2s. It's like these equations we can't derive in this method. This summation terms we can. We are always taking a multiple of multiplication of division equations. So we can write this as that's BC divided by B cube, like that kind of equation we can derive. But with some or subtraction terms, we cannot use. Say that's also you can mention there. Write the third limitation. This technique is useful only for. This technique is useful only for deducing and verifying the power relations. Deducing and verifying power relations. That's power in power relations. The right power relations, full stop. A relationship involving exponential trigonometric functions, summation or subtraction, summations or subtractions. That's right, extractor, such as extractor. This cannot be etc. That cannot be obtained or studied by this technique. Cannot be obtained or studied by this technique. By this technique. And another limitation is that some cases we can't say. We can say it's dimensionally correct, but we can't say that it's a correct equation, because all dimensionally correct equations are not the correct equation. But that's wrong. Dimensionally wrong means it's a wrong equation. But the dimensionally correct means it's not the correct, or it may be correct or not. So you can write that one also. If any physical equation is correct, or any equation is correct, it's also dimensionally correct. If any physical equation is correct, it is also dimensionally correct. But when an equation is dimensionally correct, dimensionally correct, it may or may not be, the correct equation. May not be the correct equation. I'll give you the examples for this case. You can write the example for that one. Yeah, I will give that example. This you can say that's this equation I will write there. That is equals ut plus at square, right? And when you consider about dimension of s, so it's equals to dimension of ut. right? C equals dimension of AT square. You check whether I directly know this. So I'm writing. You write the dimension of AC is L. UT has a dimension that is LT minus 1 into T. It's also L. And that AT square term also has a dimension L. So it has the dimension of L, right? So equal. But this equation now that means therefore this equation is dimensionally correct. Dimensionally correct we can say. But this is not the correct equation, right? The equation is dimensionally correct, but it is not the correct equation. So the correct equation is then, what is the correct one? That should be the number half there. That is S equals UT plus half AT square. So that's half will not be there. So but this both equations are dimensionally correct, but physically it's not correct. You can write this equation, then you can get another equation. We can say that if you write this T equals L over G, the square root of L over G, it's also dimensionally correct, but the wrong equation. The correct equation is T equals 2 5. That's I'm saying. This that's constant without dimension. So no dimensional constants. Dimensionless constants we cannot tell about anything about these things using this dimension analysis. All are dimensionally equal, but not the correct. So you can note it down, right? Hard. Okay. Again, you know, is it clear or you understand? Hello, let me know. All right. All right. Then we'll discuss some questions, right? in that questions to be given you, this first question I already done as example in the class, right? So then not going to discuss it. No need to waste the time of the second question um, that we are not discussing. We'll discuss the second one first. The swar of particles to move in a circular orbit uniformly, centripetal force is required, which depends upon the mass, velocity, and radius of the circle. Express the centripetal force in terms of these quantities, right? The given that is centripetal force. Actually, the centripetal force means when the object is moving in a circle, that all the objects they're having a force which directed towards the center of this circular orbit. So that force is called the centripetal force. When the Earth is moving around the Sun, the Earth experiences this force due to the gravity. So it's called the gravitational force, right? In any case, if a vehicle take a turn, you turn like this, so it's also the circular path. So then the vehicle having the centripetal force is supplied by the friction on tires. Right? Without that centripetal force, the object cannot be moving in a circular path. Right? So we'll discuss this in later in this lesson. And also you need to keep that if you rotate a stone, attaching to the string, so string gets tension. So that tension will give the centripetal force. Without this force, that stone cannot be moving in a circle. You know, when the string is cut, so what's happened? Then this stone will not be in this circular motion. It will be move away from this path, right? So that's right. So this centripetal force is depends on the velocity, radius, and the mass of the given like that. So then you can write the equation that F is proportional to the mass to the power A and B velocity to the power B and radius to the power C. You can write in this way. Then you can write it is the constant that K is M into A, V to the B, and R to the C. The K is a constant, the dimensionless constant. Actually, here its value of K is 1. That's not given here, that you can take it as 1. Right, that's considering the dimensions of force, you can write is mLg minus 2. And then considering the dimensions of the other side, that's k of k m to the A, B to the B, and R to the C. And the dimension of mass you can write as m. K has no dimension, m to the power A. And dimension of velocity Lt minus 1 is to the power B, and radius is L to the power C. So you can write that is m only in this one, m to the power A only. And here L to the power B here, L to the power C here. So then B plus C, T to the power minus B. Only T in this term. So then comparing the dimensions of these sides, so you can write this dimension of mu considers in right hand side it is A, and left hand side it is 0. Oh, sorry, it's 1. And length is B plus C, and left hand side is 1. And the dimension of T, that's power 0 mechanical, and this side is minus B, that's equals to minus 2. So using this you can get that is A equals 1, B equals 2, and C equals, if B is 2, the C is minus 1. So the formula you can write then F equals K m to the power 1, B to the power 2, and R to the power minus 1. So using K equals 1, then you can write this centrifugal force as mv square over R. This is the equation. to check your answer is correct or not. That's the steps and all things you need to write in this kind of question. It's okay. You got this answer? Have you got the answers like this? All right. Have anyone do the third question? So many third one. Yeah, it's very good. And what about this third one? Let me know what is the dimensions you got. I think I'm given the permission you to, yeah, you can annotate. You can write if you want anything in this board. Not only me, you also can write something. Can you write your answers? So what is the dimensions of simple A and simple B? If you want, you can write in this board. Okay, ඔයගොල්ලෝ දන්නවනේ how to use this annotation. උඩ තියෙනවානේ zoom එකේ පොඩි function bars එකක්. ඒකේ අර කෙලවරේ තියෙන dot තුනක් තියෙන එක click කරගෙන you can write this annotation කියලා එකක් තියෙනවා. පොඩි annotate කරන්න පුළුවන්. You can write colors හරි මොනවා හරි එන bar එකක් එකේ you can use the annotations. You can tell me the answer. So what is the dimensions of A? And that's they are asking you to find the dimension of A and B. Take a karada third one. That's a this equation we call the Van der Waals equation, right? That's 3 plus A over V square times V minus B equals to the R. That's the equation which that's relation between the pressure, volume, and the temperature. It's given by equation for a gas. You can write it as PV equals nRT. So this is called the ideal gas equation. But this is true only for ideal gases. Ideal or perfect gas, right? But there are no any perfect gases in our real life. For a real gas, it's a little different there. So some factors we need to change. So that's why this Van der Waals equation is corrected. Because of for a real gases, they are having the intermolecular attraction. So then it experiences extra pressure. So that's why they added this A over V square terms there. And also for a real gas, ideal gas we consider as this volume of the gas molecules are negligible. But in real gases, they are having a volume. So that's volume part we need to subtract. So that's why there's a B is V minus B there. That's N is the number of moles, but this equation is right for only one mole. So then how to get the dimensions? So to remember this method. So it is much not difficult, it's easy one, right? So here this term you can consider. You don't need to worry about the other side. You can consider about this side. That's a P plus A. That's P plus A over V square means the pressure can be added into the pressure only. So the dimensions of pressure should equal to the dimensions of A over V square. You need to get a clear idea about this. So this is true for any dimension, right? So which pressure can add to a pressure only. I mean, if the equation is dimensionally correct, this all terms, some terms or subtractions, they should have the same dimensions. Is it clear then? So then you can write the dimension of A, that's equals to the dimensions of pressure, multiply the dimensions of volume square. So dimensions of pressure is ml minus 1, T minus 2, and volume is LQ cube and star of that. So L6 then L minus 1 reduced in. So this is an ML5 T minus 2. So this is the dimensional formula for A. Similar thing you can write for the B, that's dimensions of volume should equal to the dimension of B, because it's the we can add subtract if two quantities have the same dimensions. So then this when you the dimension of B is equal to the L cube. That is the volume. How clear is it? So I will give you the one. No, right. Correct question the set again right equation. I'll give you the one. Okay, there. Then right equation. The displacement of the particle from its mean position. The displacement of a particle from its mean position. You can write the displacement of the particle, that is simple y, right? Displacement simple y of the particle. Displacement simple y of the particle from its mean position. From its mean position in simple harmonic motion. From its mean position in simple harmonic motion can be written as y equals a sine omega t minus kx. Y equals a sine omega t minus kx. Where t and x are time and distance. T and x are time and distance respectively. Time and distance respectively. Right? Find the dimensions of the term omega and k. Find the dimensions of term omega and k. Okay, you can try it and then let me know the answer. Okay, tell me what are the dimensions of omega and k? How it is? You done? Can take a photo and send me to my WhatsApp. I can check. So let's see how to do it. So here that's y equals a sine omega t. So in this kind of equation, I told you that in trigonometric functions inside, right? In this case, in trigonometric case, I will write this equation. I'll erase this part, right? Trigonometric equation here a sine omega t. Okay. Here in this part of this we have no dimension, and this sine part is also there no dimension. Something like this has no dimension. So then you can say that y has the dimension same as a. If y is the displacement, a is also the dimension similar to displacement. So then it's not asked in the question, but I'm given you that to identify it. So it's the dimension of length, right? And this no dimension. No dimension means each term inside this bracket should have no dimensions. That means omega t, dimensions of omega t is that is m0, l0, l0, t0, no dimension. It means that's the dimensions of omega that's equals to the m0, l0, t0 divided by the dimension of t. The dimension of t is that is t. So then you can write as 0, 0, t come to up then t minus 1. So dimensions of omega is equals to t minus 1. And similarly, dimension of k's term should have no dimension. Instead of writing this, you can write it as 1. So the dimension of k is equals to the dimension reciprocity of x. X is a length. This is the distance. Yeah. So it's dimension LT minus. So this is the dimensions of K and omega. So that's the way you write. If there's an exponential or any power of the quantity, so those should have no dimensions. Power exponent you don't need to consider about dimension. You can write like this. Is it okay? Okay, first let me know that what are the difficult questions you go through this and then you need to discuss. First I will discuss those questions you have difficult. So then I come to the other questions, other questions. We'll discuss this all. First you tell me that if something or some questions you have, I can explain those first. Now already we done up to the three questions you discuss. The fourth one is the here put that is this difficult one. Then I will first explain those difficulties. The sixth one, no? Right. So now we know that how to get it. Everything table like let's make according to the quantum mechanics, light travels in the form of packets of energy associated with each packet is equals the energy given as a packet. The wave or light packet of energy, that one packet is called photon. It's called a photon. The energy of a photon is given by this E equals hf. That's the if any photon having a frequency f, its corresponding energy is equal to h. H is the Planck constant. Right. So then the dimensional formula of h then equals to h. That is the energy divided by the frequency. So the dimensional formula is the dimensions of energy divided by dimension of frequency. Energy has a dimension ml square t minus 2. So frequency has dimension t minus 1. So by simplifying, you can write ml square t minus 1. This is the dimensional formula of Planck constant. Okay, then that's the case. Here we have to cover anything again. අනේ ඔයගොල්ලන්ට ඉස්සලා මාරු ටික ඩිස්කස් කරාම ලේසි. ඒකට අනිත් ටික ඔයාලට ටයිම් එක මාරු ටික ඔයගොල්ලෝ දැනගත්තාම ඔයාලට ලේසි. අමාරු කරලා ටිපිකල් වෙච්ච එක. Yeah, that's a Furness relation. In the physics, relates moving mass m to the rest mass not a particle in terms of speed v and the speed of light. This relation first arose as a consequence of the special theory of relativity due to Albert Einstein. Both because the relation are almost correctly, but forget where to put the constant c. He writes the equation as this, and in case where to put means c. So this equation you can see that's m equals m naught divided by 1 minus v square, the square root of this. Remember this equation. Actually, this is given with relativity. According to this equation, you can say that when the body is moving, its mass is increasing. හරි පොඩි එකක් වේගෙන් වෙනවනේ එයාගේ මාස් එක වැඩි වෙනවා. That's Einstein tell about this. ඒක ඔයගොල්ලෝ හයියෙන් දුවන්න එපා බර වැඩි වෙයි. Giving that's the negligible one, but it's very fast it's moving. That's like a small particles they ejecting out from in the area atomic decays processes. They come out with much equals to the speed of light. වලට වගේ approximately ඒ වගේ ලොකු velocities වලින් එළියට එනකොට their mass will increase. So here if you look at this equation, you can see in this square root, inside the square root, there's a term is 1 minus v square. But we know that if this 1 has no dimension, that v is a velocity, it has a dimension. So that part is dimensionally incorrect because that you can't subtract a dimensional quantity from a dimensionless quantity. So then this should be dimensionless. So then to be dimensionless for this term, that's the v square should be dimensionless. So then the v square should be divided by another term. That's right then to be dimensionless as v1 minus v square. If you divide it by c square, so c also velocity, v also velocity. The velocity will cancel out. So then its dimension really it's correct. So that's a missing term c you need to add as a c square there. So then the correct equation to write that is m equals m naught square root of 1 minus v square over c square. The dimensional analysis you need to use to this because that's 1 minus v square is dimensionally incorrect. To correct one, you need to put that dimensional quantity c, which is equal to the dimensions of the velocity. So then that velocity term will becomes dimensionless then when you divide it by the c square. It's clear then. නැත්නම් කියන්න ආයෙ මම කියන්න. Right. Okay, I will explain it again then, right? Here, this is the equation given, and by looking at this equation, you can see that's 1 minus v square. That's 1 is dimensionless quantity. The v square is a dimensional quantity. That is the mistake they made there. You need to identify that first because this one dimensionless quantity, right? That's v square is a dimensional quantity. So we can't subtract in this case. So we can't subtract this dimensional quantity from a dimensionless one. So if you want to subtract, they should be both should have the same dimension. Right? So then that means you need to divide this by, because to reduce that, it is it should be the dimension less, should be divided by the quantity which has the same dimensions of v. Let's say it is k, in the k star you can divide. So then this becomes dimensionless. So k has the dimension which equals to the v, right? So but it's not the same v. That's it. නැත්තම් මේක 1 minus 1 like equation එකදී වෙනස් වෙනවා. So each has the k means a different quantity, but it has the same dimensions of v, right? So then they are given that because that v is the velocity, but the c is the speed of light. The speed and velocity has the same dimension. So then you can choose this k as c, that's which has the same dimensions of v. So if you divide this by v square, then v square over c square, that's then equals to 1. That means no dimension. Dimensionally, it's dimensionless quantity. So then this equation is on. So then that's missing term c. But the question they ask you that but missing term c, where you need to put it. So that's why we need to put it there. That's as a v square or c square. So you don't need to consider about the other dimensions because that's the only wrong one to identify and take that one. Okay, then is it clear? Okay, then let me know. So other difficult questions. Today I will explain about difficult questions. So I will stop the class around 8. Then we discuss the other questions the next day, and also we will start the other lesson. 11th fun. After this session, I have to go to school also. So we have been there. The petrol chaos or in the life. So 11th they given the p equals alpha over beta e to the power alpha z and k theta. Right? This is the equation is given. The P is given as pressure. Z is distance. K is Boltzmann constant. They given the value of the Boltzmann constant, and theta is temperature. They're asking you the dimensions of the B. So first you need to identify this in this kind of V equation. This term, this part, has a no dimension. Why am I telling you that? In this trigonometric function, exponential function, they have no dimension. That's one you need to identify, is no dimension. And then also this part also has no dimension. Power of a quantity. So it has no dimension. So if I consider this, that means that alpha is it k theta. Dimensions of this being considered. It says no dimension. No? Temperature is also there. You need to consider. So then alpha you can write dimensions of alpha is equal to the dimensions of k theta. So divided by dimension of Z. Boltzmann constants they given as the value they given as 1.3 into minus 323. That is joules per Kelvin, right? So the dimension you can then find using this units. This joules per Kelvin, you can write joule means kilogram square meter per square second. That's the base units of joule and per Kelvin. So then you can get the dimensional formula of this K. The kilogram corresponding to M and meter corresponding to L square and T minus 2 and theta minus 1. Okay, this K has the dimensions in M L square T minus 2 theta minus 1. And this theta is the temperature here, and it's also having the dimension of the temperature. Divided by Z is the distance, so it has the dimension L. So now you can find the dimension of this alpha term. By this by T minus theta 1 theta minus 1, they cancel out. You can write like this. This is cancelled by this one. 1 cancelled by 1. So the remaining one is MLT minus 2. MLT minus 2. This is alpha. And if this has no dimension, so then the dimensions of pressure should equal to the dimension of alpha or beta. Okay. And also you can say then dimension of pressure then equals to the dimension of alpha or beta. That's why I will find this alpha. If you know alpha and pressure, then you can find dimension of beta. The dimension of beta then equals to the dimension of alpha divided by the dimension of already find that dimensions, that is MLT minus 2 and divide by the dimension of ML minus 1 T minus 2 also. So it is L square. So L square means it should be the area. So this is how you can get the dimensions of beta. So clear that's in the exam, they given the questions like this much of difficulties there. Is it clear? Now ලියාගන්න තියුණු නැත්නම් කියන්න කියන්නම්ම. Right. I'll explain it again, right? In these kind of formulas, there's an exponential function that e to the 1. So there's exponential function, trigonometry, or any power having no dimension. So you first identify this. So then the power of a quantity has no dimension. So you can write as a the 2 to the power x. So this should has no dimension because the power එකක් කියන්නේ එතන තියෙනවා numerical value එකක් විතරයි. So has this part has no dimension. So we consider that one. That's alpha z over k theta, they have no dimension. So then alpha has a dimension, make a it's equals to the k theta over z. So first you need to find the dimension of this k, because without knowing this dimension of k, you can't find the dimension of alpha. So how you can find the dimensions of k? That's really given the dimension of the value of k, that's Boltzmann constant with their unit. You can use the unit, you know how to get the dimension from the unit. First you write the dimension, the unit in base units, and you take a base unit challenge. So then joule has the base units, kilogram, square meter, per square second. Remember this, we all write there. Base units live one, and then per kilogram. So this, if you know the base units, the corresponding dimensions you can get it. The kilogram dimension is mass. The meter is dimension is length. The second means the dimension of time, T minus 2. And Kelvin is dimension of temperature, theta. So you substitute this dimension in here now. The dimension of K equals M L square T minus 2, theta minus 1. So here theta is there. This theta means this temperature. Each has the dimension of temperature, that theta same. This theta and per theta cancel out. So one L is there, Z is the distance, the L and L square here, one L cancel. The remaining dimensions are mass to the power 1, length to the power 1, and time to the power minus 2. Right? And then if this part has no dimension, and dimension of this side should equal to dimension of this side, so then definitely the dimension of pressure should equal to the dimension of alpha over beta in this case. If you want to find the dimension of beta, then subject the beta here, and it should equal to the dimension of alpha divided by the dimension of pressure P. Alpha's dimension already we found ml t minus 2. The pressure has a dimension ml minus 1, t minus 2. So m t minus 2, m t minus 2 cancel. So L divided by L minus 1, this comes to up, then L and L square. Clearly, you need to identify that is very exponential one, and the power has no dimension. Trigonometric one has no dimension. Inside it, you can write that is no dimension. So then unknown one, you can get using. You can write the equation for that. Right. Is it okay? Then you have any further difficulty? So I can explain another one question on. So then I'll stop the session and then we'll discuss in next week. So then you can try the other question also. That's I will write this a different one. I will discuss with you. That's question number 30, right? A little difficult. So then you can go through the other questions and then come. And next week I will discuss those, right? The 13 one is given, it's a different case. That's what I'm going to discuss with you. Here they say if force, velocity, and time are taken as fundamental quantities. Now they given that normally we taken the fundamental quantities as the mass, time, and length. But here they given that force, velocity, and time are taken as fundamental quantities, and their dimensions are F, V, and T. Find the dimensions of work. Right. So let's see. This force they given as a fundamental one, this and force, velocity, and time. No? Velocity is taken as V, the dimension of velocity, dimension of force, These are the fundamental and time. That's the work. How we write the work? Work is the force multiplied by the distance. Now we need to write this work in terms of force, velocity, and time. That's the way you need to write. And what is the velocity? You know, the velocity is the displacement divided by the time. Divided by the time. So that's displacement here. We can write that velocity into time. So we can write, because we need to write it displacement in terms of velocity and time, because these are the fundamental now. So we can write this is velocity, that's into time. So then the dimensions of work, that's equals to you can write that dimension of force multiplied by the dimension of velocity multiplied by the dimension of time. So they given that dimension of force is F, dimension of velocity is V, and so on. So this is the work in terms of this force, velocity, and time. That is the dimensional formula when you taken this force, velocity, and time as the fundamental quantity. So that's the way you can write that. This is question number 13 of this question. Is it clear? So I will give some another more question related to this type of another 2 or 3 questions. So you can go through it again. They are given some, but the 15th one also similar. Go through this all questions, then it's better. If you can write these other questions clearly, that means you got it. Okay. Is it okay if I stop the class from this point today? Because I had to go to school now. That's why. උදේ උගන්නන්න තියෙන්නේ 8යි ගානක තියෙන. ඉස්කෝලේට යන විනාඩි 10යි යන්නේ. හරි. මොකද නැත්තම් මේ ඔයගලන් දවස් මිස් වුණොත් එහෙම මට ආයෙ දවසක් නැතුනොත් එහෙම ස්කූල් පටන් ගත්තාම ටිකක් ෆ්‍රී ටයිම් එකක් නැහැ නේද? ඒකයි මම මේ ඕවන් තරම් මේ සතියම කොහොම හරි කරන්න ගත්තා. අපි එහෙනම් next week එකේ අපි new lesson එක. It's a measuring instrument we discussed. So I have many that's vernier calipers and screw gauges, every instruments I have. So we will do this the practicals also. So I will give you the instruments to do. Then you can use the instruments and you can do the practicals related to this lesson. If someone can join, so they can ask them to come next. ලොතෙන් කවුරු හරි යාළුවෝ ඉන්නවා නම් කියන්න. ඒකට මේ පාඩමක මැද හරි දිනකොට එකපාර පාඩම් පටන් අරන් ගිහලා ඒකට මුකුත් තේරෙන්නේ නැහැ. ඒක මුලින්ම පටන් ගන්න දවසේ එනවා නම් තමයි වඩා හොඳ. කවුරු හරි අලුතෙන් සම්බන්ධ වෙනවා. ඒ හින්දා මේ කවුරු හරි යාළුවෝ ඉන්නවා නම් කියන්න. මේ කියන්නේ එයාලට දැන් අපි මොකද ළඟ සති කොහොමද ඉදිරියදානේ ඉඳ කියන්නේ කොහොමද ඒක 31st නේ දැන් ප්‍රශ්නේ නේ ඒකට එතකොට next month එකට කාඩ් එක ගන්න මේ ලෙසන් එකේ හින්දා ඊට පස්සේ ඒ වෙන්නේ කියලා මේ August month එකට කාඩ් එක ගන්න කියලා කියන්නේ යාළුවෝ හිටියොත් කියන්නේ කියලා අපි එහෙනම් මේ සතියේ ෆිසිකල් කරමු. ඔයාලට එන්න පුරවන්නේ නේද? ඒක ගන්නෑ නේද? ඔව්. පෙට්‍රල් ටිකක් ගහගත්ත මං බයික් පොලිමේ. එහෙනම් මේ සතිය ආයෙ බලමු. මේ සතිය කරමු කොහොමද ෆිසිකල්. සරේ ඔන්ලයින් කරනකොට I think it's physically කරන එක තමයි නේද effective. පොත් බලන්න පුළුවන් ඕගොල්ලන් කරලාද නැද්ද කියලා. සාමාන්‍යයෙන් අර facial expressions වලින් කියන්න පුළුවන් ළමයිකට තේරෙනවද නැති කියලා තමයි. උගන්වනකොට අපිට පේනවනේ ළමයි. ඒකට මේ ඕන දැක්කහම තේරෙනවා සුබට you got it or not, then we can explain it more and more. ඒකයි අර physically කරන එකේ ටිකක් effectiveness එක වැඩි then rather than online, because online not effectively කරන්න පුළුවන්, but we need to monitor all. Then you have to switch on the camera and then I had to monitor one by one. But it is difficult in this way because if you all switch on the camera, then this connection එකත් එක්ක තියෙන මේ slow down වෙනවා. data loss එක වැඩි. ඒතකොට සමහරවිට lesson එක catch up කරන්න අමාරුයි. Let's see. Okay, then I'll stop the class. Do you have any doubts or anything? You can put the message to my WhatsApp or any other board. Una method එක දාලා හැම එකේ මං ඉන්නවා. call එකක් දීලා ඉවුවත් කවන්නේ. questions තියෙනවා නම් doubts තියෙනවා නම් if any difficulty, and also if you have any difficulty to come to the class, you can අපි තුමේ දවසක් මොකක් හරි දිස්ති වැඩක් හරි ආවිලා එහෙම ඉන්න බැරි වුණොත් මේ මට message එකක් දාන්න. මොකද මේ කියන්නේ මම සමහරලාට මම එහෙම කියන්නේ ගොඩක් මම physical class එකට ආවම ළමයින්ට කියන්නේ මේ ළමෙක් ඉතම ගෙදර ඉඳන් පන්තියට යන අතරමඟදී මොකක් හරි වෙලාද නැද්ද කියලා දන්නේ නැහැ නේ. ඒකට මේ message එකක් දැම්මොත් මම එන්නේ නැහැ කියලා මම දන්නවනේ කාදේ මෙයා එන්නේ නැහැ කියලා. අතරමඟදී මොකක් හරි වෙනවා නම් හොයලා බලන්නවත් පුළුවන්. දැන් කාලේ සිටුේෂන් එක දන්නවනේ පාරවල් වල අඬෙන්න හරි බයයි ළමයි වයවන්නේ. ඒකින්ද මොකෝලේ ඒ කියන්නේ ඩෙෆිනිට්ලි මොකක් හරි ඉඳින්නේ නැත්තම් මට මැසේජ් එකක් නිකන් දාන්න. මේ සෙපාස් එකට එන්නේ නැහැ හරි මොකක් හරි කියලා. හරි. ඔන්ලයින් නම් එහෙම ඉෂුව එකකුත් නැහැ. මම රෙකෝඩින් දාන්නේ ඒකයි මේ. එන්න බැරි වුණොත් ඔයගලන් කනෙක්ට් වෙන්න රෙකෝඩින් එක බලන්න පුළුවන් වෙන්න ඕනේ. Sigari කරොත් ඉතින් රෙකෝඩින් කරන්නේ ඒකට නෝට් එක ඉල්ල ගන්න තමයි තියෙන්නේ. Hi, I will give the tutorial that's related to theory part also and question part also. Right, so then I'll stop the class. We'll discuss the other part next week. Okay, then thank you for your participation and answer. Hi, boy.